Now, Newton's second law is about the momentum of an object. It says that the rate of change of momentum is proportional to the force on a body. Okay, the rate of change of momentum of the body. So let's try and understand this, what this is about. Now I'm going to use my favorite example of a ball. Okay, let's have the ball. Let's say we start by thinking about momentum. What do you mean by momentum? Okay, now we normally think of momentum, that momentum has something to do with motion. So let's say this ball is moving, moving with a certain velocity u. Let's say the ball has a mass. What is momentum? Right, momentum is the mass. It is equal to the mass times the velocity of the ball. So this is momentum. Now when we say the rate of change of momentum, what we mean is, if you imagine that there is a force pushing this ball. There's a force pushing this ball, force F. Then the ball would accelerate. If there's no force, we know that the ball would just go at the same speed, right? Unless there's some friction that slows it down. But if there is a force, we would expect it to go faster and faster. That means we would expect it to accelerate. Okay, if there is a force. So if you think about the momentum, mass times velocity, it means that the momentum increases. Okay, so if there's a force, the momentum increases, so that means it changes. Now what exactly do we mean by change of momentum? It just means how much the momentum changes every second, for example. Okay, so let's say after some time, okay, the ball comes here, and when it's here, let's say it would have a bigger velocity, and let's say the velocity is v. The mass is still the same in this example, but when it's here, the momentum has increased. It increased to m mass times velocity, and because the velocity here is bigger, it has increased. And during this time, the time, let's say the time is t. So that's some number of seconds. So that means that the rate of change of momentum tells us how much the momentum increases every second. That's the rate of change. Now when Newton's second law says that the rate of change of momentum is proportional to the force. What does this mean exactly? Now the word proportional has it's a very specific meaning. What proportional means is, if two things are proportional, it means that when one thing, in this case when the force changes, say doubles, then this rate of change of momentum in this, whatever it is, that is proportional to the force, this quantity has to double. So if this thing is proportional to this thing, then when one thing doubles, the other thing has to double, and one thing increases by 3 times, the other one has to increase by 3 times. So that's what happens. If the force, let's say we double the force, then it means that every second the momentum has to increase by 2 times more compared to the original force. Okay. So all this is going to be quite confusing if you're looking at this for the first time. So why not let me put in some numbers. Okay, let me put in some numbers. Let's say this mass, make things simple, is 1 kilogram. Okay, and let's say the starting velocity is say right now it's just maybe 1 meter per second. And let's say after a certain time, maybe 3 seconds. Okay, let's say after 3 seconds, the velocity increases to maybe 7. Okay, let's say 7 meters per second. Okay, so what this means is that the velocity, the momentum here, mu is 1 times 1, so that's 1. Okay, the units are just from those. So 1 kilogram meter second, and the momentum here, okay, the mass is still 1 kilogram, so it's 1 times 7, and that's 7 kg/m per second. Okay, so I'll change in momentum, change in momentum, would be mv, this one mv minus mu. That's the change. So mv minus mu, and that would be 7 minus 1, and that would be, let's see, that would be 6. It is 6 kilogram meter second. Okay, units is a bit troublesome, but there we are. So that's 6. That's the change in momentum in this example, and that happens in 3 seconds. So if you divide by the time, we'll get we'll find the change every second, and that's the rate of change. So the rate, so let me do this, let me complete this. When we say rate of, I'm just going to detour and say change in momentum, rate of change in momentum, that would be the mass mv minus mu. Okay, so that would be, okay, divided by the time. And so like I say, this will be 6. Okay, so 6 over the 3 seconds. Alright, 3 seconds from there. So finally we get an answer. Our answer would be 2. So 2, okay, that's the rate of change of momentum. Now I'm going to put in a unit. So momentum unit was this one. Now that I divide by time, some more the s at the in the denominator will gain another factor of s. So that's kg meter per second squared. So that's the rate of change of momentum. It just means that every second when momentum increases by 2. Okay. And when we say that this rate of change, alright, this rate of change, which in this case is this number here, right? We say that this rate of change is proportional to the force. So what it means is that if I double the force, if I double this force, then this momentum will increase by twice the amount every second. And if I triple the force, this momentum will increase by 3 times as much every second.